If you're watching this video, you've just watched the first video on the basics of what a limit is. We talked about the different methods to evaluate it, the definition of it, the word definition, right? And just a couple of ways to evaluate it. Okay, so let's take a look. And now we're here to do some examples, right? And so for this entire video, you might want to pause as I start an example, try it on your own, and then listen to my explanation, okay, to make sure that you're doing it right, okay? Let's take a look, and let's start evaluating some of these from what we've just looked at. Okay, so this is asking me, evaluate the limit as x is approaching -2 for this function. Okay, so where's -2? -2 is over here, right? I'll put a little line there. There's -2. If I look at it, nothing crazy is happening at -2 from the left and from the right. They're going to be the same exact values, right? It's a continuous function for myself there, right? So I can easily just look at it and say, oh, what value am I approaching? It's approaching 2. What if I'm approaching -1 from the left? And I'm going to use a different color just to so I can see this. So where's -1? -1's right here, but I'm approaching from the left. So that's what this means. Okay? I'm going to use blue, right, for this one. Right? So it's approaching -1 from the left. Oh, what value am I approaching? I'm approaching 1. Notice that I'm not caring what happens to the right side because it tells me only do the directional limit. Only do the approaching from the left side. Okay, so this one, new color again. Okay, so now I'm approaching -1 from the right. So there's -1 from the right. Okay, so I'll put the little arrow to show this is the right side of it. Okay, now some people get mixed up and say, wait, your arrow's pointing left. You're right. This just means I'm coming from the right side. So if I'm coming from the right side, I'm traveling along here, right, as I get closer and closer. So we're dealing with values like -0.5, -0.9, -0.999, -0.99999, which get progressively closer. As I'm approaching from the right side of -1, you can see I'm approaching -2. Okay. So for D, okay, now it says in general, if you're approaching -1, I'm not going to tell you direction. If you're approaching -1, what one value are you approaching? Well, there isn't one value. From the left side, you're approaching one value. From the right side, you're approaching a different value. So this would be it does not exist. It's not a no solution. It's just the limit does not exist. Okay, and then if you're have been watching Mean Girls and you've talked about where they talk about limits, right? You may remember that classic line: "The limit does not exist," and so you can say it that way to make it more fun. So anyway, the explanation, in case I asked you to explain it, you would just say the directional limits do not agree. And it's a good habit to get into explaining that so that people really know, because you know what some people do? They write does not exist anytime they don't know how to evaluate. They're like, I'm going to write that. That must be the answer. So a lot of times I do ask that question. Okay, so let's go and do the next one here. Right, so the next one, I'm going to go deep into the colors choices here, right, that I have. Looks like I have the black marker. Right, so I'm approaching 1. Here's 1. Okay, it does not specify a direction. It means I could be approaching from either side. From either side, it's approaching the same value of 2. Okay. Okay. Next, 3 from the left. 1, 2, 3 from the left. 3 from the left would be this one. Okay. What one value am I approaching? 1, 2, 3, 4, 5, 6. I'm approaching 6. Okay. Now some people say, what if you ask me to evaluate 3 from the right? It's a nonsensical statement. It just doesn't, there'd be no reason to do that. You really would never be asked for that. It wouldn't even be does not exist. It'd be like, I don't know, shenanigans or something like that. This just doesn't make sense. So it's not, it does not exist there. It's just nonsensical. It's like writing 3+, right, for yourself. Like you just don't do it because it doesn't make sense there. Okay, I guess if it was written, you would just say, doesn't make sense. So I don't know. Okay, so 4 from the right. Take a look at 4 from the right. Okay, purple marker comes out here. Right, so 4 from the right. Right, so here's 4 from the right side of it. I'm coming this way. I'm approaching -1. And if I'm approaching 6, and I think I'm going to go back to the pencil for this one. 1, 2, 3, 4, 5, 6. If I'm approaching 6, right, you can see that nothing special is happening there. It's continuous. The left side is approaching 0. The right side is approaching 0. The function has a value of 0. It's just 0 there. That's all we have to do. Okay? Okay, let's take a look at this next one here. Now, notice for this next one, right, I gave you the function here, right? So while the graph may not show it, this is an open circle. That's not filled in. Okay? So it's just like, you can see it's kind of the same as this one up here, except there's on both sides. So, okay. So, good time to pause, try it on your own, then check to see what you have. Limit as I approach -3. Where's -3? Right here. Okay, nothing special is happening at -3. Right, so that means that the left side and the right side are agreeing. It's continuous there, right? So that's going to be -2. So the directional limit is really, this whole thing didn't matter for the answer. Oh, so that means the next one's -2 as well. Oh, and the general limit is also -2 because the left and the right agree. Okay, what about as I approach 0? As I approach 0, that's going to be this value right here. Okay, from the left side of it, I'm approaching -1. From the right side of it, I'm approaching -1. The general limit is -1 because the two directional limits agree. But if I actually want to find the value at 0, that would be no solution. It would not be does not exist there. Right? Some people write does not exist, but technically, right, it's a no solution. There's no solution to it. Okay? Yes, the value doesn't exist, but we say that with a no solution there. Okay? What's important to know is you don't use no solution for a limit when you're doing it. You should always write does not exist there. There is not a no solution. Okay? So that's just one of those the ticky-tack things that you have to worry about with notation. Okay? So what we see for this one is that the general limit can be found, right, even if the function doesn't exist. Okay? So it's worth noting that if we look at this original function that we have right here, and if I was to reduce it, remember we did rational functions last week, right? We reduced it, and if I factored out, those would cancel. Okay? If it reduced out, and then I look at it, hey, then, okay, I should really say here that x cannot equal 0, which tells us why it doesn't exist there. Right? But you can see that for that function, that x reduced out there, right? And then we can still find the limit. Okay? You can also see, if you think about what we did last week, right? As we did this last week, we talked about, hey, if sometimes you can just plug in the values and it's okay. And while it wasn't okay here because I had a 0 in the denominator, if I was going to evaluate the limit for this guy right here at 0, I was going to evaluate that limit. Since the denominator's 3 no matter what, the numerator, well, this is approaching 0, so that if I take a number that's approaching 0 and I subtract 3, that's -3. Hey, you can see that's the limit right there. So this gets into technique number 3 for methods. Okay, so we could also plug in to the function, and you can see that you can't just evaluate in the function if it's continuous, but as long as it's, we see in this case that you can evaluate just as long as you can reduce out the discontinuity. So if it's continuous at the x value, or the domain restriction is reduced out. Okay. This technique of plugging in to evaluate is really nice to use, right? Especially if you don't have a graph there, right? But we just have to make sure that it's, right, we can just see that it has to be, we have to know it's continuous there. We don't pick up the pencil point, right? or you have reduced it out. Okay. Next example here, right? Last example. This is the big one, right? It keeps, tons and tons of it. Okay, so you should have pause, try it on your own. If you can do this, then you totally understand everything we do. Okay, so I'm actually not going to explain this one because I feel like it's just a lot of redundancy there, right? But I will post this with the solutions online, so you can kind of check that you did it right. Okay, so hopefully I explained that real well, and you understand everything. If not, email me, right? Stop by a Google Meet, right? Whether it's the extra help session on Friday or just want to do other regular sessions Monday or Wednesday. Thanks a lot, guys, for listening.